Hi everybody, Hal Pickering here once again with my final video for the Toolmaking Competition for 2017. I've had a few goes at making this Vernier marking gauge. The first one I made was with the shape of a file handle, but I didn't really like the way it turned out, the way I was planning to mount the Vernier on it. It just didn't look right. So then I took a bit of advice from Mr. Pete Toolmaking, and he recommended that if you're not sure what you're doing, to make a wooden one first. So I took his advice on that one. You're never too old to learn something, and made a couple of wooden prototypes. And one of the prototypes I made will satisfy those comments I got on making something that's easy, where you don't need a lot of specialist tools. So let's take a look at how it progressed. I started off with this one, which is the shape of a file handle. I sort of copied this file handle. It's not a bad marking gauge, it's worked out quite well, but the idea I had to mount the Vernier, it just wasn't going to be any good. I was going to mount the Vernier on top like that, with a block under the back here, but it just looked too clumsy. I didn't like it, but this has worked out quite a nice little marking gauge. It's just not a Vernier marking gauge. So then I went on and tried to make a wooden one. First of all, made a wooden shape like that in the little South Bend lathe, something that would be comfortable to hold, and that had potential. And then I went a bit further and made a bigger one, and I unscrewed the little Vernier scales which sit on the they sit on the main body of the Vernier here. They were screwed on with 1mm screws. So I took them off, drilled them out to 2mm, which is all I could get because it's just about breaking through the edges. And then what I planned to do was to screw them in to here and have a couple of steps in there. So my piece of 1/2" key steel would go through there, and then the main body or the stem of the Vernier would fit into there, and then those little Vernier scales would sit in the final step, which is just up there. So I went and made a new template to run in the little South Bend lathe. This one here, I also had a template for that, for the file, and I'll just do a short clip on those. This is the other prototype that I made out of wood, and that is just a block of wood that was about 50mm square, and I've cut a section out there to mount the main body of the vernier in there where the scales are, and I've screwed it onto the back of the piece of wood with 2 screws. This is one of the other verniers. So I've just put 2 countersunk screws in there, and then cut off all of the legs. Everything was cut off. Had to do it with an angle grinder because these verniers are surprisingly fairly hard. An ordinary file will only just touch them. So I think a file from memory is about 64 Rockwell C scale. So I think this vernier would be up in the high 50s, and there's no way I could cut it on the bandsaw or anything. I just had to cut it with an angle grinder, and then dress all the edges back with just on the offhand grinder, and the same with the end here. So then I've screwed that onto the piece of wood, and I've screwed a little block of steel on the end here, and I will drill a hole through there to take just an old broken tap, which I'll sharpen up, and put a grub screw through the end here to hold it in position, and that'll be calibrated by the thickness of this wear plate on the end. So it's just a little bit narrow at the moment. If I drill a hole through there, I'll take my screws out. So I'm going to have to thicken up that plate so that I can get that broken tap down through between those screws, and so I need a thicker wear plate on here, and then I can calibrate it by just grinding the tap with a flat on it and clamp it with the grub screw on the end. But for anyone who wants a simple way of making it, that was all cut out by hand. I did mill the little trench in here, but you could cut it with a saw if you're a good carpenter, and it's just screwed into the back there. So once the tool goes into that, you'll just read off your vernier the size you want, clamp it, and then you can just scribe your line just like that. And the only machines I used to make that was an angle grinder, a drilling machine, offhand grinder. As I said, I did use my mill, and if that was polished up a bit and stained, that's quite a good little marking gauge, and that was a prototype. The final one that I made, which I've finished off now, is this one. It has a wear plate on the bottom here, just screwed on with 2 countersunk screws. It's got the 1/2-inch key steel running through it. It's got the new shape which I made in the little South Bend lathe with a template, and it's got quite a nice feel about it when you wrap your hand around it. The 2 little vernier scale plates have been put on there by drilling and tapping the aluminium body, and I took those out to 2mm. The original vernier was 1mm, which was just too small. 2mm taps were bad enough, let alone 1mm. There's a little insert in here, 10mm threaded rod, and locked in with a nut. That way your locking screw is running through steel instead of running through the aluminium. The scriber is a piece of 3/16 square tool steel, and to calibrate that it goes up against the face there. So when that's up against the face, the vernier reads 0, and what I did there was I actually surface ground this face here until I got my 0. That needs to be pulled up so that it's only just sticking out enough to scribe a line. Otherwise you create I'm pretty sure it's called a cosine error if you had this tilted over at a bit of an angle. The vernier stem is just screwed on to the 1/2" key steel with just one 3mm screw, and there's a clearance hole through there to hold the 3/16 square tool steel, and I cut that little square there on a slotting machine. There's also a pointer in here which is exactly 5mm from that face, and when you bring that tool down so it's level, that becomes a set of tremels or a set of dividers, whatever you want to call it. This is acetal black plastic on top of the aluminium body here, and it takes the vernier caliper, the main stem of the vernier. It's a bit hard to see, but there's the slots in there taking the vernier. This clamps onto a little piece of brass. It's a little brass plug, sits over the clamp screw, and that's the tapping size of the 10mm screw. So that's it. I've got a little job to do for a neighbour who wants a motor changed from a 3-phase motor to a single-phase motor, and I've got to make some adapter plates for it. So I might do a demo on marking out those adapter plates, but here's a few short clips on how I made this gauge. Here's a little demo of the marking gauge. I've got to mount a motor on a wood saw bench. This fellow wants to change it from 3-phase to single phase. So I bought a new motor, and of course the holes didn't line up in the base, so I've had to make some adapter plates, and so I thought this might be a good example of how we can use the marking gauge. I've made up a rough drawing because the saw's up in a wood workshop a few kilometres away, and I've got the new motor here, so I've got the sizes for that. So first thing I'll do is mark out the 32 dimension here along these bits of plate, which are 75mm by 10mm thick. The new motor will bolt on here, and the old holes in the mounting plate on the machine are that hole there and that hole there. They'll all be tapped at 10mm. So let's do a bit of marking out. First size is 32mm. So take the marking gauge and set it to 32mm. I don't know whether you can see that line there, but I can just see it. I'll do the other side. Right, so I did spot one hole through the motor, and the line that I just marked is along there, and you can see that hole that I spotted. So what I'll do now, the centre distance for the holes on the motor is 125. So now I'll set the gauge at 120, and I'll use the Dremel divider pointers on there. As I told you before, the little pointer is 5mm back, so you've got to look at the overall length of your centres minus 5mm. So we'll set it now at 120mm. And we'll drop the tool bit up here. I'll drop that down until it's approximately level, just to eliminate cosine error. And now, if I can get it in focus here, I can put one end in the centre punch mark and mark a radius there, and that should have ended up, if I can put the ruler on there, should have ended up 125. So I think you can just see that there. I'll do the other one. Here's a summary for this final video. If you remember, we started off with this one. Used that for quite a few years. Then I made this one, shape of a file handle, with the idea of putting the Vernier on top, which I didn't really like. I have finished this off a bit. I've put the tool in the end here. I've put a scale in it here. It's got the wear plate on the back here. That little flat there on the scriber is to calibrate it, and it also has the points underneath to use as a pair of calipers or a pair of dividers. It's worked out okay. It's not a Vernier marking gauge, but a nice marking gauge nevertheless. I then made this wooden prototype, and that's turned out pretty good. Made a thicker plate on it so that I could calibrate it to 0, and I've done that. I've actually put a little notch in the end there so that the tool bit goes right up into the notch, and when that tool bit's faced level there, the Vernier's on 0. I've also put this little clamp on the end here. It saves you searching around for a Allen key when you want to adjust it to turn it into a pair of dividers, like so. The handle's been polished up a little and stained, and for anyone who hasn't got the fancy machinery, that's a nice little Vernier marking gauge to make. The final one, which was this one, looks really nice. It's nice to hold. Got the square key steel in it, makes it very sturdy, and it's turned out pretty good. But I think if this one was made with a aluminium handle, I think this one would probably be the best one. It's the easiest one to make. I think I overdid it a bit with this one. It's a bit over-engineered. I put a lot of thought into it and a lot of work into it, and it does the same job as this one. This one's easier to make. It's lighter, and I think when it's all said and done, I think this one is probably the best one. But I'll be interested in your thoughts and comments. Thanks very much for watching, and I'll look forward to your comments.